Hi, I'm Oliver Willett.
And I'm Jonah Guy.
We're from Happy Valley Elementary School, and we're in 6th grade.
In Santa Cruz, California. And we made
The Splash Bag. Our friend's Paige has a disease called pulmonary hypertension, or PH. She has to wear a pump, like a diabetic does. Unlike a diabetic, Paige cannot take her pump off because she needs a constant flow of medicine. Her pump cannot get wet. We wanted to solve this problem.
Our solution to this problem was to repurpose a phone dry bag into a pump dry bag to hold a CAD MS3 pump. We could put the pump in the dry bag, but we needed to find a way for her medical tubing to come through the dry bag but still keep the dry bag watertight.
We decided to try to contact our friends' doctors at Stanford to see if we could borrow a non-working CAD MS3 pump to help us with our design process and stuff. They agreed and were very excited about our project.
So next, we talked to my neighbor Hal, who used to waterproof electrical wires for AT&T. He gave us the idea to take a nail the same thickness as the tubing and heat it up on the stove. Then, take the hot nail and clamp it into the plastic seal of the dry bag, hereby melting the plastic and creating a sort of channel to let the tubing go through.
After we made the channel, we needed to test if it was tight and still allowed the medication to flow through. So, in our first test, we stuck a paper towel inside the dry bag and put the dry bag into a bowl of food color dyed water to make sure that we could be able to see that it was actually the food color, actually the water, you know? So when we submerged it in the water for 2 minutes, there was some water on the paper towel, meaning that our prototype had not worked. When we opened up the dry bag, there was only a hole at a channel at the top of the seal, not at the bottom of the seal. To prove this point, in our second test, we stuck the dry bag into the hole, into the water with only the paper towel and not the tubing. No water got in, meaning that our hypothesis, our guess that there was only a hole in the top was right. On our third test, we modified it so that there was a hole in the bottom, a channel on the bottom, so that the channel ran all the way through. When we tested it, there ended up being no water in the bag. To prove that our tube wasn't being crimped, then we filled the dry bag up with water and squeezed it to see if any water came out of the needle at the very end of the tube. Water only came out of the needle and not anywhere else on the dry bag, meaning that there was no crimpage in the dry bag, in the tubing.
In conclusion, it works. When we mailed the test pump back to our friends' doctors at Stanford, they were so thrilled that they requested to feature our splash bag invention on the Stanford PH website. We are so proud that our invention can help Paige and others with PH.
Thank you.
Thank you.